Hello, everyone. My name is Sergey. I work at Percona as a group product manager, and today I'm going to take you to the journey on dynamic user creation for MySQL on Kubernetes with HCP Vault. Sounds a bit scary, but I'm going to walk you through, show you a nice demo. So let's go for it. So yeah, a bit of an agenda. At first, we're going to figure out the whys behind, okay, what do we want to do here? What is this dynamic user creation? How it helps? How Kubernetes comes into the picture? What about HCP Vault? What is it? And so on. Then I'm going to talk about the how. So we're going to unmask a bit the details of what we want to do, how to do it, how to cook it, what is the secret source. And moving forward, we are going to have a quick demo. So I will show you that it actually works, that it actually possible. And I hope that out of this talk, you will see that running databases on Kubernetes is not scary. Having dynamic users is useful, and it can help to improve your security. All right, so let's go. The whys, right? Again, dynamic user creation, Kubernetes, how it all fits in, HCP Vault, no idea. So databases, right? In a nutshell, databases are quite simple, and the story is the following. You have a user or an application on the left, and on the right, you have a database. And both application and the user, they want to do something with the database. They want to get the data, they want to insert something, they want to drop some tables and databases, right? And to do so, obviously, database needs to know who is it? Do they have access? So we talk about authentication and authorization. And the simplest form of it is to give your users and applications specific passwords and usernames. Kudos to all of you who know what these passwords are, by the way. So, but once you give out these usernames and passwords, it is not that secure, right? Because this can happen, for example, right? Or this can happen. Some rogue pull request or send by mistake to public repository, and your database is not that secure anymore, right? Obviously, it should not be publicly available and so on. But obviously, I'm exaggerating here. So I really hope that no one is going to put a sticker with the database password on the monitor, right? We kind of have this experience already. But talk to your security team, talk to DevSecOps team, and I believe they have an interesting stories to tell about leaked passwords, hacked databases, and so on. So it is a problem. The passwords can be a weak link in your security protocol, and they can leak for sure, right? And the solution that we're going to look today into is dynamic users and passwords. How it works is the user or the application first goes to HashiCorp Vault and nicely asks for dynamic credentials. Please give me my password. HashiCorp Vault does some magic behind the scenes and returns the password and the login to the user or the application. And then we move forward to connecting to the database with these credentials provided to us by HashiCorp Vault. So this is the super high level view of what we're going to talk about today, right? And definitely if these passwords are random, so we have totally random user, totally random password, it is awesome, right? Another aspect here is that this user and password, these credentials, they provide you with the limited scope. They do not allow you to access the full data on your database. or just the subset of it, and you might have only select permissions, so you can only read the data and so on. It depends on your configuration, the one that you define. And also these credentials, they have an expiration date, which means they were dynamically generated for you. You use them for 1 hour and then they expire and you need to request the new ones, right? This is the whole purpose of this dynamic credentials, so that they expire and they rotate automatically. So you kind of enforce your security policies here automatically, which is awesome. And again, your security team would be extremely happy about it, right? Now, let's talk about the why on Kubernetes. Why do we have it here? Frankly speaking, we can do any database deployed anywhere and it would still work. For me, it's just simpler to run database on Kubernetes nowadays. If I want a database cluster to play with, I usually use our operators to do that. Recently, I was trying to deploy a MongoDB cluster on regular VMs, and it took me some time because I had to Google all the configuration parameters and see how I can connect them to each other to set up the replication and so on. And with the operator, I don't need to think about it. It just works out of the box. I run a couple of commands and that's it. And yeah, at Percona, we really love our operators and Kubernetes story. For those who don't know, operators is just a piece of code that allow you to run applications on Kubernetes. And on top of that, it is important that it also allows you to manage your applications. So in case of the databases, it means you can take backups, you can restore the data, you can upgrade, you can scale, you can start it, and you don't need to do it directly going to the containers or to the pods. You can do it through the operator, just send some commands through a YAML manifest, and that's it, which is awesome. Our MySQL operator at Percona runs on PXE, Percona Extra DB cluster. It is a highly available solution for MySQL clusters with synchronous replication provided by Galera and regular MySQL. It is 100% compatible with MySQL, right? What is HCP Vault? Hope everyone knows what Vault is, right? It is identity-based security solution. So it helps you to store your passwords, certificates, and many more in a third-party place, let's call it like that, right? And then once you need, you securely can retrieve them and use them to connect to your applications, databases, and so on. And the HashiCorp cloud platform is just a fully managed offering for Vault. So you can deploy it on your own VM or your Kubernetes cluster, or you can go into a nice UI and click a couple of buttons and have Vault deployed for you and managed for you as well, right? So what we're going to do today is we're gonna use it, right, and see how it can connect to our database. So on high level, again, I'm showing you this picture. This is how it's going to look like. So the user or the application connects to the Vault, right? And the idea here is you go to the Vault, ask nicely for a password and well, for credentials, you get it, and then you connect to the database. Looks simple, but in reality, something else is happening in the backend, right? And today we're gonna talk about it. So first of all, we'll need to configure our MySQL. As I said previously, it's simpler for me to deploy it in Kubernetes, but it can be any other MySQL deployment, right? So we have Percona Extra DB cluster deployed with the operator on Kubernetes. What we need to do to prepare for HashiCorp Vault integration is to create the user for HashiCorp Vault, right? This user is going to be used to create dynamic users on the database specifically. And we need this user to have grant permissions, because obviously we will be creating users, we need grants, right? And if you know how MySQL permission policy works, you also need to grant select, for example, if you want to allow the user to select data, your dynamic user to select data. I'm going to talk about it a bit later. Also, we're going to create an exemplary dummy database called MyApp. This is the database that we're going to connect to with our dynamic users and passwords, and we're going to limit the scope for our dynamic users to this specific database only. So this is what we're going to do on the database side. I'm going to show it in the demo, right? Now, we need to prepare the vault itself. To prepare the vault, we need to first enable the database secret engine. It is a secret source for dynamic user creation on HashiCorp side, right? HashiCorp Vault side. And again, I'm going to use a cloud version of it, so I'm not going to show how to deploy it, how to configure it. It is going to be taken care of for me, the same as with the operator. Then we're going to need to configure HashiCorp Vault to connect to our database. Basically, it's just providing the endpoint and the username and password that we created on the previous step on the database side. And also, we will need to define the role for dynamic users. This role is actually what is going to limit the access for our dynamic users inside the database, where they can connect from, what kind of data that they can work with, what can they do with this data, can they select, insert, and so on. So this is the role, how it looks like. And again, I'm going to show it in the demo. In bold, you see, okay, we're talking about my app database that we just created. We're going to grant the following. So select, insert, update, kind of excessive permissions, but it's just for the sake of demo. Again, my app database here, the user will be able to connect from anywhere. Well, not a good idea in production environment, so you'll need to change that probably in real life. But for the sake of them, again, it's fine. And here you see this TTL. So by default, these credentials, dynamic credentials, will be valid for 1 hour only. And the TTL can be extended to 24 hours. Again, security team would be happy with this enforcements, right? And again, now let's talk about connecting the dots, right? So we have, you see 1, 2, 3, and 4 numbers here. So the way it's going to look like, users and applications, they go to HashiCorp Vault and ask for credentials. Once they do that, HashiCorp Vault connects to the database and creates dynamic users on the database side in the database. So just based on our role. After that, HashiCorp Vault goes back to us and says, hey, here are your dynamic user credentials, please use them. And then only then we can connect to the database. As you see, I also have HE proxy here and load balancer. The story behind it is that our operator at Percona also creates HE proxy so that you have a highly available proxy in front of your database to balance the traffic, to balance the reads and writes. And also, if you run on public cloud, for example, then you probably want to expose your HE proxy to the outside world so that the users can connect, and we do it with the load balancer. In case of Amazon, it's going to be NLB or ELB, doesn't matter, right? And in our case, both HashiCorp Vault and our users and application connect through this load balancer, which is probably not a good idea. And actually, the recommended setup looks like this, right? So If you're familiar with Amazon, they have this VPC, virtual private networks, right, that are running in specific Amazon accounts. And if you want to use HashiCorp Cloud Platform in production, the recommended setup is that you have HashiCorp Vault deployed in a private VPC running in HashiCorp Amazon account. You have your applications, users, and database in your own VPC in your Amazon account. It is also private, and then you interconnect these two accounts through VPC peering, right? So we should always think about security not only on password level, but also networking level. And for the sake of demo, I'm going to expose my Vault cluster to the outside world, to the public internet. The same I will do with the database, but only for the sake of demo. Don't try this at home, because it's much simpler for me to do it like this versus setting up the VPC peering and all of this, right? So yeah, now we are ready to go into the demo. Okay, so demo, right? Let's start with HashiCorp Vault clusters. So this is the portal of HCP, HashiCorp platform, right? As I said, you just click a button and your Vault is deployed, which is awesome for me, not to spend any time. And again, I'm exposing my Vault publicly, right? I'm going to copy it and I'm going to reuse it a bit later on. I'm not sure if we copied it correctly. Let's see, copy. Yes, looks like fine. I copied it in my notepad to use it later. Okay, cool. Now I'm going to generate the token. Again, publicly exposed Vault is not a good idea. Don't do this. As I showed you before, better set up proper VPC connection to the platform, and then you would be able to secure your traffic flows. So don't do that. Okay, good. So I copied the token. I'm going to use it later on again in the demo. Now let's jump into the console. So I'm going to show you what I have here. So first of all, I have PXE cluster running. As you see, I have 3 pods. This is my MySQL cluster. And I have 3 pods for HE proxy. So, well, it is highly available. And I have the operator. Operator is just controlling the database and the HE proxy and ensures that everything is up and running. You see the status is ready. And you can also see here an interesting thing, endpoint. As I was saying, again, I'm not doing a good thing here. I'm exposing my database publicly through a Google Cloud load balancer. So this is the IP address that I'm going to use to connect to my database. Good. What I also need is I need a root password. Our operator automatically generates passwords for the database for root and system users, and stores them in Kubernetes secrets. And here is just a command to extract this secret object from the password for root from secret. Okay, now let's connect to the database first. MySQL -u -e -h. I'm going to use this IP address, and this is my password. Copy paste. Let's see. Yes, I can connect. Awesome. What I'm going to do now is I'm going to create a user so that our Vault can connect to our database. The user would be HCP, and it's going to be super duper password. Okay, good. Not a good choice as well. Now, grants. I'm going to allow this user to select, insert, update, delete, drop, create, alter, and also I'm going to have grant options. This is important because I want to create users and grant them some permissions, dynamic users, right? So let's go, and flash privileges just in case. And I'm also going to create our empty database to which we're going to connect. You will see it later on. Cool, all done. Good. Now let's work with the Vault. Now we need to configure the Vault. As you remember, this is the endpoint that I copied, and the Vault namespace is going to be admin. Let's try to log into this one. Vault login token that I have copied. It's this one. Let's paste it and let's hope for the best. Let me see. Where is it? Public copied. Okay. I need to check if I can connect to this one actually. Let's wait a bit. It might take some time. Or it's not going to fail. ALS, HashiCorp Cloud. Yeah, looks correct. No? Okay, let's it happens sometimes. Okay, it resolves. What about port? Yeah, I can't tell that. Maybe I have wrong integration here. Maybe. Not sure. Okay. Now looks correct. Let's try again. Oh, I think I see what's going on. Yeah. I think I copy pasted the wrong one entry. Let's try again. Vault login token again. Here I come. Oh yeah. Now it worked. Okay, it looks like wrong URL. Sorry for that. Good. Kind of relieved. Now we're going to enable the database engine, right? Database secret engine, which is the secret source to create dynamic users on the Vault. It is like a plugin for it. And we're going to configure Vault so that it can connect to our database. I would need again our database endpoint. For that, this is it. Okay. Again, I will copy paste quickie. Okay, there you go. So you see, I'm saying, okay, this is my username and password, HCP super duper, and this is my endpoint to connect to the database, which is an IP address of my HE proxy, which I just copy pasted. And also one interesting thing here, my SQL role, allowed roles, you see. This is something that we're gonna copy paste right away. Here it is. It's what you saw on the slide. It is the role which actually tells HashiCorp what kind of user, dynamic user we want to create. The user should have the following grants, and it should have access to my app database only, and it can connect from anywhere. These are the default and max TTLs, right? Let's do this. Yep. All good. Okay, so we have successfully created everything. We have configured our database. We have created the user. We have created the database there. We configured our Vault, and now we're ready to create some user, right? Dynamic user. Let's do this. Okay. Now you see, I have the username and password randomly generated. List duration is 1 hour. Interesting. Let's try to connect to the database. MySQL minus user. A user would be this guy. Minus password, minus host, it's going to be this guy. And remember that we have access to connect to my app database only, right? Otherwise, we would get an error that we don't have access. And the password is this one. Okay. Yep, it worked. Show databases. Let's see the scope. Okay, we have access only to my app database. This is what we wanted to have, right? Okay, this sounds great. Let's see if we can create more credentials. Yes, we can create lots of them, right? And they will be used by other users or by other applications. Okay, let's get back to our slides. This is actually the last slide. So in this demo, in this talk, you learned what dynamic user credentials are, how HashiCorp Vault helps to top up your security in your environment and enforce your security policies, right? And also I showed you the nice demo on how to do it and integrate it with a Kubernetes operator and all the bells and whistles, and it kind of worked. Now I'm ready to take your questions, and also feel free to reach me at the email you see on this slide and on Twitter. We'll be glad to chat. Thank you.